So good morning. Here are the questions on the final exam, the topics for the final exam. And I'm so glad that this is the last day of class. Significant figures. Significant figures. There are two different types of rules, but I want you to remember the rules for multiplication and division. Get your calculators out, calculate this, put it in the right significant figures, and we can move on. So what's the rule? Yeah, the smaller number of significant figures. So this one has 3, this one has 2 significant figures, right? And the smaller is 2, so the answer should have 2 significant figures. What about this one? It's division. The rule is the same. There are 3 here, 2 here, so the answer must have 2 significant figures. So those are the answers. 1, 2.5, 2.5, because there should only be how many? 2 significant figures. You got it. It's not a good start. Anyway, that'll be fine. Number 2, kinematics in 1 dimension. Bunch of equations. But the question is, do you know what the terms stand for? If you still do not, you're going to be in trouble. There are 5 terms. What are they? Initial velocity, final velocity. And what do you know about acceleration? It's constant, right? Constant acceleration, time, displacement. Those are the 5 terms, and then you have a bunch of equations using those 5 terms. Each equation only has 4. This is 1. Very simple. It does not have what? It doesn't have displacement. So that's why you read the question. If nothing is spoken about displacement, you use this equation. You have to make it up. Here's the second one. There's no mention of time. So that's the equation you use if there's no mention of time. The third one is what we call the king. No final velocity, isn't it? No final velocity in that equation. Do you all remember a fourth one that I gave you that does not have acceleration? Are you all making your own formula sheets? Yes. Okay, focus on these formulas, please. Here's the one. The average velocity multiplied by time. That equation does not have acceleration in it, right? Those are the 4 equations. Here's what they stand for. Initial velocity, final velocity, displacement, time, and acceleration. And I told you that the acceleration needs to be constant. So take this as an example and try to work this out. So here's the thing. Don't shout it out. Please don't give the equation. Give everybody a chance. I've given you the initial velocity. So this problem might say an object starts from rest, right? If an object starts from rest, what is its initial velocity? 0. And I say its final velocity is 12 meters per second. In moving through 100 meters, find the acceleration is the question. So you got to list down the 4 quantities, including what you have to find. Then take a look at your formula sheet. Try to find out the equation that has these 4, which means it does not have anything to do with time, right? That's it. That's all you have to do. You have to look at it, list it down, look at the equation. This has time in it, this has time in it, this one doesn't have time in it. So that's the equation to use. Plug it into the equation, calculate, you get the answer. Now, why shouldn't you be able to do it? So for those who worked it out, you would have used that equation, plugged it in correctly, and presumably you know how to manipulate that. And you should get the answer as 0.72 meter per second squared. Is that right? Is that what you got? Yes. Okay, how many got that? Let me see your hands. Okay, so number 3, velocity and acceleration. Both are vectors, so there is a problem. There could be a problem there with velocity and acceleration. Now here is one question. Try to listen to me carefully and give me the answer. An object is moving to the east and accelerating, means speeding up. What is the direction of its acceleration? An object is moving to the east and speeding up. What is the direction of its acceleration? To east. What if the object is moving to the east and slowing down? What is the direction of its acceleration? West. To the west. That's what I want you to know. Here is the diagram for that. If both the velocity and acceleration, if it's accelerating, then acceleration is in the same direction. If the object is moving to the east and decelerating, then its acceleration is in the opposite direction. Is that clear? I want you to understand that. Then I want you to answer this question. An object is thrown vertically up, all right? At the highest point, what is its velocity? Anybody will answer that, I know. Come on, go.
0.
Very good. Any object thrown vertically up, right? It's one-dimensional motion. At the highest point, its velocity is 0. But here's the real question. What is its acceleration at the highest point? Negative 9.8 meter per second squared. Now, students are not able to separate velocity and acceleration. They're like, when an object stops, how can it still be accelerating? Acceleration due to gravity is always negative 9.8 meter per second squared. Do we know that? Yep. So it doesn't matter where the object is. Acceleration due to gravity is always negative 9.8 meter per second squared, even when the velocity is 0. Are you with me? So if I ask you a question like this, can an object have 0 velocity but yet have an acceleration? What would your answer be? Yes. Or if my question is the other way around, suppose I ask you, can an object have 0 acceleration but yet have a velocity?
Yes.
See, I heard 2 S's. Come on.
Yeah.
Can an object have 0 acceleration and yet have a velocity?
Yes.
Yeah. That means it's moving at a constant velocity. Isn't that what it means? So multiple choice conceptual questions, be careful, read it. I'm checking if you really understood the topic. If you understood, it'll be like, so easy. That was number 3. Number 4, falling objects. Like I said, don't try to copy everything, but instead listen to me, because when you go back home, you will see this there. Now, here are 2 objects. Both are projected horizontally from the same height. Are you listening? One object has half the velocity as the other. So this is like half the size as this, right? Almost. So both are thrown horizontally from the same height. And I want you to tell me which object takes a longer time to fall to the ground. Thank you so much. It takes the same time. Now, if my second question is, which object will fall at a greater distance from where it is thrown? Like, it's already there in the diagram, the figure, if you watch carefully. Which one will travel a greater distance along the x-axis? The one that is thrown with a greater. This is all that I want you to understand. Okay? And now if I ask you to calculate the time, when I give you some terms, you will have to use this equation to calculate the time. So, here are the examples. What is the initial vertical velocity of this object? What about this one? Why are their vertical velocities 0? Because they are thrown horizontally, right? Yeah, because they are not being thrown up or down. Can you in your mind separate these two? Is that clear? This object has a horizontal velocity, but its vertical is 0. Same thing with this. I know when I said that this would be double, but in the example, this is 50 and this is 60. I know 60 is not the double of 50, okay? Yeah. Anyway. So can you now with this find the time it takes to fall to the ground? Go ahead. Find the time it takes to fall to the ground. Obviously, I'm not thinking about significant figures there. But is that what you got? Now, did you all remember that G has to be negative 9.8 always? And why is delta Y negative 98? Because it's going down. Okay? So if it was going up from where it was thrown, you would take delta Y as positive. If it's going down, you would take it as negative. There you go. That's the next concept. Weight and mass is the next one. Weight and mass. What do you know about them? Mass is a constant. Weight changes from place to place. Now, why does weight change? Because weight is defined as mass multiplied by acceleration due to gravity. So if you take an object to the moon, wouldn't its weight change? Would its mass change? So could you find its mass on the earth and use the same mass on the moon? All right, very good. And force is mass times acceleration. Isn't that what we get this from? Because weight is a force. It's the same formula. That is Newton's second law. So find the weight of that object. Find the weight of that object on the earth. Don't say it, don't say it, don't say it, Conan. Don't say it. Find the weight of that object on the earth. Now I'm going to be walking around looking. Tan theta is 1.28, and then take the arctan of that. You should get 51.9 degrees. Did you get that? Let me see the hands of those who got it. Ember, you didn't get it? No. Okay, check out why. Help her out, what she's doing. Find out. Work out the same problem, assuming that there is no banking. Okay? And find what the coefficient of friction should be. You don't need the mass. You only need what I've given you. You only need the velocity and the radius. So that's where you have to think. I know when you look at it directly, you go like, oh, the mass is there. Think a little bit. Don't say it to anybody. Let them think. Don't say it. If you get it, write it. I want to see how many get it. So if there is no banking and there's only friction, mu Fn is equal to mv squared by r. Question now is, I have not given you mass, so what do I do? Sit and cry? No. So who got the idea of why mass need not be given? Look at Maggie has the idea. There are 2, 3, 4, 5 people. You have the idea? Anna, tell me why. How? No. You don't see mass on the left side. That's mu, yeah. Fn is not mass, but Fn is mass times gravity. Because on a flat surface, Fn is straight up, mg is straight down, isn't it? That's the key. On a flat surface, mg is down, Fn is up. So Fn is equal to mg, therefore you can write mu mg is equal to mv squared by r. Now the masses cancel out. What did you get for mu when you substituted this? I don't have the time. Come on. 2.2? 1.2. Can mu be 1.2? What's the maximum value of mu? 1. Which means practically this car cannot stay on the road. You know what I'm trying to say? Because it's moving too fast. What if it had been driving? So I can ask you this. What's the maximum speed at which it can drive? Then you would have to put mu as 1 and find that speed. Does it all make sense? Yeah, because the maximum value is mu is 1. Put that and find it. So that with that, everything is clear. The next topic is work, potential energy, kinetic energy. Work is force multiplied by distance for you. Potential energy is mgh, and kinetic energy is 1/2 mass times velocity squared. So I wanted to find out the work done in lifting a 5 kilogram object to a height of 10 meters. Don't shout the answer out. Find the work done in lifting a 5 kilogram object to a height of 10 meters. Oh, he didn't give us the force. He didn't give us the force. That is the mass. So what do? I can't do it. Physics is so tough. It's not. You just have to think. What did you say, Vanessa? Due to gravity. Correct. What is the force required to lift a 5 kilogram object? Its weight. If this object is seated here, how much force should I apply to lift it? Its weight, right? That is common sense. What is the weight? mg. And what's the distance you moved it through? 10 meters. So aren't you using mgh? The work done in lifting an object is called its potential energy. The work done in lifting an object is called its potential energy. So that's what I'm checking for if I ask you a question like that. Instead of giving you the mass and the height and say find potential energy, which anybody would do without understanding anything. That's when you turn this into a math class. This is not a math class. Okay, so can you get the answer now? Work done is mgh. And you should have got 490 joules. Did you? Joule is the unit of work and of energy. Because energy is the ability to do work. Are you all listening to me? Good. Next topic, angular velocity, omega. Angular velocity is omega, defined as theta by t. But omega is also 2 pi times f. What does f stand for? Frequency. What do you mean by frequency? The number of rotations in 1 second. Number of rotations in 1 second. So that's frequency. Or omega can be 2 pi by t, where t is tiger. No, sorry. What is t? Time period. What do you mean by time period? Time taken for 1 rotation. So again, frequency is the number of rotations in 1 second. Time period is the time taken for 1 rotation. Are you with me? If you are, go ahead, find this. If an object makes 500 RPM, find its omega. If an object makes 500 RPM, find its omega. So you're like, what is RPM now? What is RPM? Rotations per minute. Is that frequency? It has to be in a second, right? So now it's like, how do you change this to per second? If it makes 500 rotations in a minute, would it make more number of rotations in a second? Are you crazy? 1 minute is 60 seconds. Now listen to me. Look at me. 1 minute is 60 seconds. So in 60 seconds, it's making 500 rotations right now, isn't it? 500 rotations per minute. Come on. Is 500 in 60 seconds? So in 1 second, would it be able to make more number of rotations? So what do? Do you divide by 60 or multiply by 60? Divide by 60. Major mistake that students make. Because they go by 1 minute and 60 seconds and multiply it, which is crazy. Which would be like 3,000? No, 30,000 rotations in a second. Don't do that. So again, when you change RPM into RPS, divide by 60. Are you all listening? Divide by 60. Once you do that, how do you get omega? Once you get, that will give you F, right? And then what you do is you multiply by 2 pi. That's it. So F is 500 by 60 RPS, which I think comes out to be 8.33. Let me know if I make some crazy mistake. And then put it as 2 pi times 8.33, which gives you 52.37. The unit of angular velocity is radians per second. Radians per second. Well, if it's multiple choice, then you don't have to worry about units most of the time. But if it's those 4 essays carrying 10 points each, 10 times 4 is 40, then you got to be worried. All right. Conservation of momentum. Conservation of momentum. Who can state the principle of conservation of momentum? I think I should have exams like that, you know. State the principle of conservation of momentum. Gianna, can you do it? What is the principle of conservation of momentum? Gabby? Anybody? Jesus, go.
That when potential energy is equal to negative?
No. That's conservation of energy, you're thinking. Conservation of momentum.
The momentum before collision is equal to momentum after.
But there is a condition. Momentum before collision is equal to the momentum after collision, but there is a condition. What is the condition? No, that's different. Yeah, what is the condition? Huh?
Outside force?
Complete your statement. You're just saying outside force.
Object in motion will stay in motion.
No. You said outside force, but make the statement complete.
No outside force.
No outside force acting on the system. So what is the conservation of momentum? Total momentum before collision is equal to the total momentum after collision if what? No external forces or outside forces act on the system. So when two objects are colliding, you can't go and kick it. That would mean that would be an external force. See that? They could exert a force on each other, but not from outside. All right. So here are two people who do not like each other so much. They are pushing against each other, and they are standing on ice. Ice. Okay? Ice. Standing on ice. Sleet. Pushing. I'm trying to say there's no friction, which means there's no external force, isn't it? What is the velocity with which the 60-kilogram person would move? Find it, don't say it. I know on the exam, diagrams won't be given, it will be sentences, right? It will be the same thing, right? A man of mass, a person of mass 80 is pushing a person of mass 60. If the person of mass 80 moves at 3 meters per second to the west, what is the velocity of the other person? This one, everybody knows, because I've also given a diagram that the 60-kilogram person is moving in the opposite direction. Doesn't everybody know that? Like, I've given you a diagram. So if this is 3 meters per second, the other one should be negative something. Come on now. Shouldn't it be? Yeah. If this is taken as positive, the other one should be negative. Doesn't matter which one you take as positive or negative. They should be opposite. So who can get the right answer? Okay. What is the initial total momentum?
240.
No. What is the initial total momentum? What do I mean by initial? Before they push against each other. It's like they're ready to push. They're right there. They're not pushing each other yet. What is their initial momentum? Thank you. So you got to put 0 is equal to, now after they begin pushing, what's the momentum of this guy? 240 plus 60 times x. Do that, you get the answer. Go ahead. That's how you do it. Stop. Is this clear? What am I saying? The total initial momentum is equal to the total final momentum. That's where physics gets you. Apply the principles. Then when you switch sides and do that, you know you're going to get a negative and divide both sides and get the answer is -4 meters per second. And your grades will look good. You got that before? Connected systems. Another favorite? Connected systems. Didn't we talk about this the other day? We did. So it's coming back again, which means it's on the exam. Connected systems. Now, does that make sense? It's a repeat. Come on, does it make sense? What are the forces acting on this object? Its weight and the tension in the string. What are the forces on this object? Its weight and the same tension, isn't it? Okay, that's why you have to pay attention. In this object, in the case of this object, and so this is a capstan, so it's a bigger mass, okay? In this object, which force, Susanna, which force is bigger? T or mg? Okay, what direction is this object moving in? Therefore,
Wait, what?
this is the heavier mass,
Oh, down.
this is the smaller mass, so this mass is going
Down.
down. Therefore, which force should be bigger?
MG.
Exactly. So when you take the net force, you're going to take mg minus t. But when you take the net force for this one, which force is bigger? This is moving up, isn't it? Come on. Which force is bigger? Therefore, when you take the net force here, what do? T minus mg. That's what you do. And it's when students miss that step, that they could get confused. They're like, because you're not listening. So mg minus t is equal to ma. For the second one, t minus mg is ma. It's easy if you understand. You try to memorize, it's so tough. It won't work. Does anybody have a question on that? Have I explained it clearly? I think I have. Aren't we using Newton's second law here? Because it says net force is equal to mass times acceleration. Come on. Isn't that true? Okay, now if you have to find the acceleration, you add these two equations. What is the advantage of adding these two? You get rid of tension. Can you put all this on the formula sheet? No. You can't set up systems of equations. Okay, so would that equation give you the acceleration? Yes, you just have to plug in the numbers. So now I want you to do this to check if you understood. I just changed it a little bit. What's the change? Now you have one object, the smaller mass, moving on a frictionless table. Okay? And you have the bigger mass moving vertically. Can you find the acceleration of the system? And I'm going to give you a few minutes. Find the acceleration of the system. Or give me a formula to find the acceleration of the system. Can you give me the equation for the lighter object? Put your hand up. That's 3, 5. Okay, not enough. All right, we'll wait. Everybody else, look at the forces acting on this object. Now, these are vertical forces. Do they contribute to the motion of the object? They don't, because this object is moving along the x-axis and these forces are along the y. And didn't I tell you it's a frictionless table? So you don't even care about those forces. There is only one force along the x-axis. What is that force? T. So that's the net force. And that should be equal to mass times? Correct. That's it. So write those two. You will get it as mg minus t is ma. For the second one, you get that. You add the two equations, get t out of the way, and you have the formula. So here are some numbers. Find the acceleration. Find the acceleration. The bigger mass is 50 kilogram, the smaller mass is 10 kilogram. Find the acceleration. String. Find the tension in the string. So you find the acceleration and find the tension in the string. All right, so in this one, when you substituted, I'm thinking you should have got this as the answer. Is that what you got? 8.2 meter per second squared. And then you put it back into this equation, or this one, if you want to take the tougher route. You will get your answer. And I did not find the tension. I just made that up now. So what do you get? T is m times a. So that would be, what is it? 10 times 8. Actually, you know, you should use the number before you round it when you calculate. Did you know that? Wasn't it 8.17? What was it?
8.167.
Okay, so 16717 maybe. So that's 81.7. So that's how you do that. Young's modulus, elasticity. Young's modulus. Do you even remember what that is? Who remembers? Nobody? We didn't talk about it? Yeah? Okay, here it is. If you have a steel cable, no, we're talking about it now. It's easy to understand. You have a steel cable, like in a crane. You know what I mean by a crane? Okay. Not the bird, but the other crane. And if there's a big load attached to the steel cable, don't you think it'll stretch a little bit? Not as much as a rubber band. That's why we don't use rubber bands for cranes. That'll be funny. So steel, although it's steel, it'll stretch. So in this formula, here are the terms. F is the, okay, you tell me, what's F? Force applied at the bottom of the cable, which will be mg, isn't it? Mass times acceleration due to gravity. What is this? The original length of the cable. What is this? The area. What area? The area of the cross section. What shape does the cross section have? Circle. What is the formula for area of a circle? Pi r squared. Do I have to know that? Yes, you have to. And it is not 2 pi r, okay? Pi r squared. That's what you have. Is it pi r squared? 2 pi r. How do you know? Because the unit is meter square, isn't it? So it cannot be 2 pi r. 2 pi r is the circumference. So pi r squared. What is this term? Change in length. Okay, have I explained all the terms on the right side? Let's go again. The force, which is mg, the original length, the area of cross section, and how much the cable stretches. Now on the left side, what do you find is called a constant. It's called Young's modulus, name of the scientist. This topic is called elasticity. Which is more elastic, rubber or steel? I got you. Steel. Elasticity is not how much it stretches. Elasticity is how quickly it comes back. You stretch rubber a few times, forever it'll be stretched. You know that? So which one is more elastic from today? Steel. Have you heard it? Because you'll have it in your head the wrong way. Elastic means you apply a small force and it becomes, no, that's not elastic. When you remove that force, will it come back exactly to its original length? That's more elastic, okay? That's why bridges, buildings are all made of steel. You make a building out of rubber and live in it. I will not, okay? So here's a problem. Try to do that as an example. So if the original length is 5 meters, I've given you that. The extension is 1.8 millimeters, which I change in a meter. And the radius is 1 millimeter. Okay, what did I do? I said the radius is 1 millimeter. What is this? Radius is 1 millimeter. What is this? You have to change in a meter. How do you change a millimeter into meter? Divide by 1,000 or multiply by 10 to the negative 3. And then you have a square because it's r squared. When you do all that, you get that. So be careful on this. So that's the area in meter squared. Yes? No? So I've given you that. And I'm also giving you the Young's modulus. It's a big number. And I want you to find the mass that causes this. The Young's modulus is 2.0 times 10 to the 11 pascals. It's the same unit as that of pressure. Can you find the mass? Now, you need a few minutes for that. All right, so for the sake of recording it, so when you work it out, and hopefully I get the same answer. Otherwise, that would be really funny. Let's wait for this to roll. Give me a few more seconds before my fate becomes clear. Okay, so for the first time in history, I wrote something correctly. Okay, go.
You said the Young's modulus is a constant, so you'll give it to us? Like,
Yeah, that's the Young's modulus for steel. It'll be given to you.
Okay.
Yeah. Yep.
I have a question about.
All right, next concept. Simple pendulum. Have you heard of a pendulum? What is the formula for time period of a pendulum? That's oscillations. That's our last chapter. 2 pi square root. Yep. So if the time period is 2 seconds and g is 9.8, can you find the length? Go ahead. Time period is 2 seconds, g is 9.8. Find the length of this pendulum. So if you did it the right way, you have to square both sides. And when you square both sides, lots of students forget to square this. I'm glad you did not. You did remember. You have to square this also. And then the square root is gone. And then just simple substitute into that. Rearrange. You should get the answer. So how many of you got 0.99 meter? Let's see your hands. Did you get it? 0.99 meter? Yeah, that's how you do this. Now, why did I pick 2 seconds? That is the time period of a pendulum in a pendulum clock. And I think I've told you that. 2 seconds. 1 second to go this way, 1 second to come back. So the time period is 2 seconds. See that? That's how it works. So each time it swings, the minute hand goes, or the second hand rather. So the next topic is torque. Torque. That symbol is tau. It stands for torque. And what's the formula? Okay, RF sine theta. What are those letters standing for? Radius means distance. That's the force, sine of the angle. All right, take a look at this diagram. The force is being applied this way at this point, and let's say this is a door or something that turns about this point. Are you watching? It turns about this point, okay? So, is this the distance? No, the distance should be from the point where the force is applied to the point about which it rotates. You heard me? So that's the distance. So I'm going to give you the distance, I'm going to give you the angle, and I want you to find the torque. That's all. Find the torque. Oh, I didn't give the distance. Take the distance as 1 meter. Take the distance as 1 meter. So this distance is 1 meter. All you have to do is put it into that. Get it in a few seconds, please. Got it? 1 times 500 times sine of 30. 250 Newton meter. That's the unit of torque, because torque is force multiplied by distance. All right, the next concept, moving on. Pressure. What is the formula for pressure? Generally, E3, what's the formula for pressure? Force over area. Pressure is force over area. What is the unit of pressure? We've used it today, pascals. So, but what is the formula for pressure exerted by a liquid? Now that's the formula generally, but what about a liquid? G. Yep. Pressure by a liquid is H rho G. So 2 formulas that I want you to remember, and please remember this is only when it's a liquid. This is in general. So here is a problem for you. If the mass is 100 kilograms, the area is 0.1 meter squared, find the pressure. Too many times, that's true. 9.8 times 100, so 9,800 pascals. All right, next concept. Expansion of solids when heated. Expansion, okay, thermal expansion. The formula is change in length is the original length times thermal expansivity times the change in temperature, okay? How much it expands, straightforward formula. So if the original length is 100 meters and alpha is given to you, and change in temperature, so the initial temperature was like 20 and the final is 200. Final is 200, then what you do is just this and put it, you get the, okay, what is that? Is that the new length? Okay, so if I ask you to find the new length, what do? Add that to 100. Okay, don't forget, that's it. That was a question on the exam, you remember? Yeah. So then it would be 100.180 meter. That would be the new length. Can we move on? Okay. Ideal gas equation. There is one question on that. There's one question on each topic that I've talked about today. So what's the ideal gas equation? PV is equal to an RT. Explain the terms. Let's go. With the units, come on, help me out. What's P?
Pressure.
In
Pascals.
pascals. Volume in
Cubic meters.
meter cube. Number of moles in no units because it's a number. Gas constant, which will be given to you, 8.314 joule per mole Kelvin. T, temperature in Kelvin. Oh my, I found a couple still using Celsius on the exam. T must be in Kelvin. Okay, so now you know all those. So for example, if the volume is 30 meter cube and there is 50 moles of a gas at 300 Kelvin, find the pressure. Go. You're ready for anything. Okay, so what you would have got is Did I do it correctly? Is it 4,157 pascals? Yep. All right, so that's what we get for the pressure. Moving on. Heat. Simply heat. There are two ways. One, if an object gets heated up, you use MCAT. Remember MCAT? What are those terms standing for? M is the mass, C is the specific heat, and change in temperature, right? Change in temperature, okay. But if it's a change of phase, like melting of ice, boiling of water, then what's the formula? M times its latent heat. Agreed? So you've got to be reading the problem and look at it and say, hey, is this a change of phase? If something melting or something is boiling, use this. If it's simply heating or cooling, use this. Can you write that by its side? Yeah, write it. Heating or cooling. This is change of phase. P-H-A-S-E, phase. Right? So here is an example that you work out. It's on the exam. The numbers are different. 10 kilograms of ice is at minus 10 degrees Celsius. You got to melt it completely. How much heat is required? 10 kilograms of ice is at negative 10 degrees Celsius. Ask me for constants if you need them. Be specific about what you need and I'll give it to you. You need the latent heat, okay. But is that the first thing that you need? All right. Yeah, because ice would not melt when you start heating it. What's the temperature? Right now, what's the temperature of ice? Negative 10. Will it start melting? Ice has to get to 0 degrees Celsius. So, on the exam, if I give you this question differently, let's say on the exam, if I tell you ice is at 0 degrees Celsius, in that case, the only formula you have to use is because it's already at its melting point. Did you hear me? But in this case, you'll have to need the specific heat of ice. It's 2100 joule per kilogram Kelvin, 2100. So use 2100, do that. And the latent heat is 336,000. 336,000. So 2100 and 336. So that's the C. Okay, and so when you do that correctly, you will get the answer. Now, when you take the change in temperature, it has to be final minus initial, right? So 0 minus 10, you know what I mean? So don't put a negative there. Because it's heat being absorbed. Negative heat would mean heat is being rejected. So,
Oh, so you wouldn't change it to Kelvin?
Okay. Vanessa is asking, wouldn't you have to change it to Kelvin? What do you say?
No, because you're taking.
I mean, there's nothing wrong if you change, but then you would get the same difference, wouldn't you? Because 0 would be 273 and minus 10 would be 263. So the difference is still 10. Good question. Okay, so if you are in doubt, always change into Kelvin. That's good. So that gives you 2.1 times 10 to the 5. Is that what I got? Is that what you got, rather? Okay. And then for the melting process, you get this. And then you got to add them both to get the total quantity of heat. Because the question was, how much heat is required? Louis, you're getting it? So that part is to heat the ice. This is to melt it. So add them both. Be careful. And you get the answer. Carnot engine. You just need to know the terms. Efficiency. Can somebody help me out with those? What is this term standing for? Work done, isn't it? And what is work again? It's QH minus QC. Okay, what is QH? Heat absorbed, and QC is the heat rejected. So work is QH minus QC. It's coming up on the screen. But there's also another formula for efficiency in terms of temperatures. T, correct. TH minus, you don't even need a formula sheet. You see that? TH minus TC by TH. So there are two formulas. Here, temperatures have got to be in Kelvin. Be careful, because some people may think, yeah, it's a difference. Yeah, in the numerator, it's a difference. But what about in the denominator? It's not, right? So it has to be in Kelvin. Well, I did not give you an example on that. The last topic, I think, motion on an inclined plane. I had to bring this in because it's a little different from banking. So if you're not paying attention, this diagram will look like the same diagram for banking, but it is not. Somebody tell me the difference. The difference is in how the object is moving. In this case, the object is moving either up the plane or down the plane. But in the other one, it's moving across, isn't it? The road was that way. It was moving across. You see that? So therefore, I wanted you to see a big change that happens. I'm sure you get it. Are those the two forces that we had in the last case too? Same thing? mg vertically down, and what's the other one? Fn. Do you remember the case of banking? Which one did we break up into two components? But in this case, mg. That's the difference. That's all I want you to remember. In this case, you break up mg into two. You get mg cosine and mg sine. You do not do anything to fn. So those are the components. Can you remember that? It will be like, which one is which? You have to complete the triangle to be able to do that. If you complete the, I can even draw a little bit there. Hopefully you won't get confused. Let me just, that's my right angle triangle. Isn't this the opposite side? Come on. And the opposite side would be sine. That's why that is sine. I mean, this here is the same as this. Instead of drawing it here, did you see what I did? I just drew it there. So that's the opposite side. Isn't this the adjacent side? And so it has to be. That's how you remember. And then once you remember that, what is the acceleration? If there is no friction, what is the acceleration? What is the formula for acceleration? Force divided by mass. What is the force? mg sine theta. Not mg. mg sine theta. Isn't it going down this way? mg sine theta. What is the mass? m. So the acceleration is just g sine theta. The acceleration is always g sine theta if there is no friction. And I think I tried to ask you a question without friction. And deliberately I became so good to you. A is g sine theta. That's all you have to remember. And so if theta is 30 degrees, then you would get 4.9. Check it out. Would you get 4.9 meter per second squared? Then I don't know if I did that, but let me add on to this. So if I ask you, how much time does it take to slide down a distance of 2 meters, starting from rest? Can you do it? That would be a great question, because now I've combined two topics, right? What is the time taken for an object sliding down from rest through a distance of 2 meters? So, haven't you already got acceleration? Come on. So what equation comes to your mind? Very good. Delta x is equal to V naught t plus 1/2 at squared. So there is kinematics there. And of course the first term becomes 0. So the second term, come on, 1/2 times 4.9 times t squared, and then when you do all that, you are going to get t as, somebody's going to give me the answer,
It's 0.9 seconds.
0.9? Yeah, that sounds right. It's a small time because it's just 2 meters. Last one, projectile motion. One last time, projectile motion. I think it's an essay question. In projectile motion, if I give you the velocity of a projectile as 10 meters per second and the angle is 30 degrees, can you go find the time taken for it to go from ground to ground? Go ahead. I've given you the initial velocity, I've given you the angle. Find the time taken for it to go from ground to ground. Take some time on this. When you break the velocity into its components, what do you get on the x-axis?
8.7.
How would you get that? That's right. You would get 10 cosine 30. Why cosine? You can see that's going to be the adjacent side, isn't it? Yeah, that's going to be the adjacent side because the angle is taken there. So there's no need of confusion there. That is the adjacent side. So 10 cosine 30. And the vertical would be 10 sine 30. So that's what you do first. So 10 cosine 30 and 10 sine 30. So that gives you 8.67 and 5. Stop and ask questions if you have any. You got that? And then that's the complete trajectory. And what is delta y? Very good. Delta y is 0 because it started from the ground and ended back on the... But what if it had ended on the top of a table 1 meter high? In that case, delta y would have been plus 1. What if it had ended into a hole 1 meter deep? That's all. Now, you have it covered. If you can remember that, you got the 10-point question. So again, if it goes from ground to ground, delta y is 0. If it starts from ground, ends up on a higher object, it's positive the height of the object, right? If it ends up in a hole, it's negative the depth of the hole. So delta y in this case is 0. I was asking you to find the time. So to find the time, you would use the vertical component, isn't it? VOY, which is 5 meters per second. Acceleration is always negative 9.8. You're asked to find the time. This is the equation you use. We've used it a couple of times already. That's why we call it the king. And then don't go crazy. Substitute carefully and do that. And when you see t on both sides, when you see 2t and t squared, don't get upset. Because can't you switch sides? See what I'm doing? Next step. 4.9 t squared is 5t. Did that make sense? And then cancel out, get time as 5 by 4.9, which is almost 1 second. Did anybody get it before I did? Yeah? 1 second. And then I want you to find out the distance from A to B. The distance from A to B. What would you do? With the velocity along the x, because you're finding delta x, VOX, that's where you use your 8.67 multiplied with 1 and you get 8.67 meter, and that is how you prepare for your final exam. Thank you and good luck.